بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are review exercises about chapter 2, which is about quadratic equations and functions and applications. So find the real solutions to each quadratic equation. We studied two methods to solve quadratic equations. The first one is factoring. And here we can factor the left-hand side. If we take x as a common factor, we will have 4 minus 3x equals 0. And we have the zero product property, which says either x is 0 or 4 minus 3x is 0. So this is the first solution. And here I can take 4 to the other side, and then I can divide by -3. So -4 over -3 is 4 over 3. So these are the two solutions of this equation. The second equation, x minus 1 times x plus 3 equals -8. Well, I cannot use the zero product property here because this number is not 0, it's -8. So I have to expand. The only way I can solve this problem is to expand these two parentheses. So x times x is x squared, and the inner is -x, and the outer is 3x. If you add 3x minus x, you get plus 2x, and -1 times 3, and I'll bring -8 to the other side. And then I have the quadratic equation, x squared plus 2x minus 3 plus 8, that's plus 5 equals to 0. And I may try to factor this equation. If I factor x squared to x times x, and then I can search for two numbers. Their product is positive 5, and their sum is 2. Well, there is no numbers like this. So I cannot solve this problem by factoring. So the second method to use is to use the quadratic formula. So A is 1, B is 2, C is 5. And the quadratic formula says that x, the solutions of this equation, is given by -b plus or minus square root of b squared minus 4ac over 2a. So b is 2, so this is -2 plus or minus b squared, which is 4 minus 4 times a is 1, so I'm not going to write it, and c is 5. Because 4 times 1 is just 4, so no need to write the 1 in the multiplication, over 2 times a is 1, so 2 times 1 is 2. So I have -2 over 2, let me write it like this, plus or minus square root of, this is 4 minus 20, so this is -16 over 2. So in fact, this is -1 plus or minus. Square root of -16 is not real. Actually, it is 4i over 2. So the answer is 2i. So the two solutions of this equation are not real. And he is asking about find the real solutions. So I can say that no real solutions. So this equation has no real solutions. If I have an equation like this, I can use the square root property, which says if x squared equals k, then x is equal to plus or minus square root of k. This is the square root property. So to use this property, the coefficient of x squared has to be 1. but I have 4 here. So I need to divide by 4. So x squared would be 3 over 4. And now I can use the property. So x would be plus or minus square root of 3 over 4. But this means that x is plus or minus square root of 3 over square root of 4, which is 2. So these are the two solutions. Here, this is a quadratic equation. First step is to take everything to the left-hand side. So this is negative 8x squared. If you take it to the other side, it would be positive. So 8x squared plus 8x squared would be 16x squared, and plus minus 1 equals to 0. If you look to this equation, you notice that the first term is a perfect square. It has a square root, which is 4x. And the last term is also a perfect, no, it's not a perfect square because it is negative 1. So the square root of negative 1 is not real. So how can I solve this equation? Uh, Let me use again the quadratic formula. So if A is 16 and B is 8 and C is negative 1. A is the coefficient of x squared, B is 8, B is the coefficient of x, and C is the constant term. So I use the quadratic formula, which is x equals negative b, so it's negative 8 plus or minus square root of b squared, which is 46, minus 4 times a, which is 16, times c, which is negative 1, over 2 times 16, which is 32. So it would be negative 8 over 32 plus or minus square root of. Now this is 64 plus minus times minus will give you plus, plus 4 times 16, which is again 64. So we have square root of 28 over 32. And if you simplify 8 over 32, that's 1 over 4. And square root of 128 is 64 times 2. So 64, the square root of 64 is 8. And I'll have square root of 2 inside. And then 8 over 32 is again 1 over 4. So the answer is 1 plus or minus square root of 2 over 4. And these are the two solutions of this equation. Here in these questions, find the vertex and determine if it is a maximum or minimum point. Find the y-intercept and the zeros if they exist, and sketch the graph. Here we have quadratic equations, and we know that the graph of any quadratic equation is a parabola, and the vertex has coordinates. The vertex of the parabola has coordinates hk, and we can find h using this formula, negative b over 2a, where b is the coefficient of x, so negative 2 because b is 2, so a here is a half, b is 2, so negative b would be negative 2 over 2 times half, which is 1, so h is negative 2. And k, we find k by replacing x here by negative 2 by h. So it's half times negative 2 squared plus 2 times negative 2. So k would be, this is 4 over 2, 2 minus 4. So it's negative 2. So the vertex of this parabola is negative 2 and negative 2. Now A is positive. If A is positive, the parabola opens upwards. And this means that the vertex is the minimum point. So it is minimum. The vertex is minimum point. Uh, find the y-intercept. Well, the y-intercept, when we put x0, if you put x0, half times 0 plus 2 times 0, you get 0. So the y-intercept is 0. Find the zeros if they exist. Well, the zeros, we put y0. The zeros, we put y0. They are the x-intercepts. The zeros are also the x-intercepts. So we put y0, so we have half x squared plus 2x equals 0. Now, I can multiply by 2 to get rid of this half. So x squared plus 4x, because I multiplied by 2, equals 0. And if I take x as a common factor, then either x is 0 or x is negative 4. So I have two zeros for this parabola. Now to sketch the graph of this parabola, the vertex is at negative 2, negative 2. So this is the vertex, and it opens upwards because A is positive. 0 is the one x-intercept, and negative 4 is the other x-intercept. So this is the graph of this parabola. Another question. A here is negative 1 over 4, the coefficient of x squared. B is 0 because it's the coefficient of x and there is no x here. So h would be negative b over 2a, so it would be 0 over something, so it is 0. K, if you replace x by 0, you get 4. So the vertex is 0 and 4. A is negative, so this parabola opens downwards and the vertex is maximum, the maximum point. The y-intercept, if you put x0, so the y-intercept is 4, the vertex actually. The zeros or the x-intercepts, I put y0. So I have 4 minus 1 over 4x squared equals 0. I have only x squared in this equation and a number, so I'll use the square root property. So I take 4 to the other side, and then I multiply by negative 4. So if you multiply by negative 4 here, you get 1, and negative 4 times negative 4 is 16. So x would be plus or minus square root of 16, which is 4. So these are the zeros or the x-intercepts. So 1, 2, 3, 4, this is the vertex, and this is the x-intercept, and this is the second x-intercept, and the parabola goes downwards like this. So this is the graph of this parabola. Another question, A is 1, B is negative 4, A is 1, so it opens upwards, and the vertex is the minimum point. And h here would be negative b, so it's 4 over 2 times 1, which is 2, so h is 2. And k would be f of 2. I replace x by 2, so it would be 4 minus 4 times 2, that's 8, plus 5. So 4 minus 8 is negative 4 plus 5 is 1. So the vertex is 2 and 1. Well, the vertex is 2 and 1, and it opens upwards. Okay, so that we can find the y-intercept by putting x0, so the y-intercept is 5. So this is the y-intercept. Okay, and once I know the y-intercept here, I can find another point on this parabola. Now this is 2, and if you go 2 units to the left at 0, y is 5. So if I go 2 units to the right at 4, y also should be 5, because the line, this line in the middle, is the axis of symmetry. It's an axis of symmetry. So this distance should be equal to this distance. You can see from the graph that there are no zeros or no x-intercepts. If you try to solve this equation, you will get uh, non-real solutions. Okay, b squared minus 4ac, which is the discriminant here, would be 16 minus 4 times 1 times 5. So it would be negative 4 less than 0. So no real solutions. And we understood this from the graph, that the graph will not intersect the x-axis here. Another question. Here a is negative 4, coefficient of x squared, b is the coefficient of x, and c is the constant term, negative 9. H would be negative b, so negative 12 over 2 times a, so negative 8. So 12 over 8 is 3 over 2. And k would be 12 times 3 over 2, which is 18, minus 9, minus 4 times 3 over 2 squared, which is 9 over 4. So 4 cancels with 4. And then I have 18 minus 9 minus 9. So the answer is 0. So this means that the vertex has coordinates 3 over 2 and 0. Well, A is negative, so the parabola opens downwards, and the vertex here is the maximum point. The y-intercept, if I put x zeros, the y-intercept is negative 9. The x-intercepts, or the zeros of this function, let me put y0. So I have negative 4x squared plus 12x minus 9 is 0. Now let me multiply the equation by negative 1. So the coefficient of x squared would be positive. If you multiply by negative 1, you change all the signs. Now look here, 4x squared has a square root, which is 2x. 9 has a square root, which is 3. Now 2 times 3 times 2 is negative 12. So actually these three terms can be written as perfect square like this. So whenever you have a square minus 2ab plus b squared, you can write it as a minus b to the power 2. You take the square root of a square and the square root of b square and multiply a times b times 2. If you get the term in the middle, then these three terms can be written as a perfect square. The only solution of this equation, that 2x minus 3 equals 0, or x is 3 over 2. So that's the only x-intercept. So let us try to sketch the graph of this parabola. X is 3, the vertex is 3 over 2 and 0, so it is here. This is the vertex, and the parabola opens downwards to go like this. It goes like this, and that's why it has only one x-intercept. 9. This is -9. So this is the y-intercept of the parabola. Okay, and this distance from the vertex to the 0 is 1.5. So if you go 1.5 to the right, you will also have -9 because of symmetry of this parabola. So this would be the graph of this parabola. So in the middle, this line is the axis of symmetry. And here it has the equation x equals to 3 over 2. And it's always have the equation uh, of x equals to h because it's a vertical line. Find the average rate of change. Well, the average rate of change by definition is f of b minus f of a over b minus a. So B here is, let us say, 50 and A is 30. So I need to find f of 50 minus f of 30 over 50 minus 30. So f of 50, I replace x here by 50. So 100 times 50 minus 50 squared. Okay, the answer is 2500. Minus f of 30, I replace x by 30. So 100 times 30 minus 30 squared. That's 2100 over 50 minus 30, which is 20. Now 2500 minus 2100 is 400 over 20. The answer is 20. So this is the average rate of change of y from 30 to 50. Sketch the graph of this basic function. We know the graph of x squared. It is the parabola. The vertex is 0, 0, and it goes up like this. 1 over x is the reciprocal function, or it's also a rational function. And we know that this function has a vertical asymptote, x equals to 0, and a horizontal asymptote, y equals to 0. And the graph is like this, approaches the asymptotes. Of course, notice that the domain of this function is all real numbers, while the range is from 0 to infinity. While here, the domain is all real numbers except 0, and the range is also all real numbers except 0, because y cannot be 0, and the x also cannot be 0. Find f of 0. Well, 0, where is the equality here? X is less than or equal to 0. So f of 0, I will replace x here by 0. So I have negative 0 square, which is 0. If this number 0.0001, this number is less than 0, is it, or greater? No, it's greater than 0. It's a positive number, greater than 0. So I use the second definition. So 1 over 0.0001. And if you divide, you will get 10,000. F of -5. Well, -5 is a negative number and it's less than 0. So f of -5 would be minus -5 to the power 2. So I replaced x by -5. So it's negative, and -5 square is 25. You cannot multiply the negative by the negative because there is a square here. You have to square first. You have to raise to the power 2 first. F of 10, well, x is greater than 0, so I use the second definition. So f of 10 is 1 over 10. graph each function. This is a piecewise function. Look how to graph the piecewise function. The important number here is 1. So this is x here is 1. Now when x is less than 1, I need to graph y equals to x. This is the first definition. If x is greater than 1, I'll graph y equals 3x minus 2. Well, both are straight lines. So I need 2 points to sketch the graph of each one of them. So I replace x here. You can make a table of coordinates. Okay, you choose 2 points. I choose 1 here and 1 here because 1 is the number in the middle. Okay, greater than 1 there is a definition, less than 1 there is another definition. So I have to use 1 here and here. If x is 1, y here is 1, and if x is 1 here, 3 minus 2 is also 1. So at 1 1, this is the graph of y equals x. Okay, uh, and then I choose a number less than 1 for this function. So 0, for example. So at 0 it is 0. So the graph goes like this. This is the graph of y equals x. Okay, let me do it in a better way. Okay, of course you graph it here in this region, okay, to the left of 1. So you do not continue the graph to the right of 1 because to the right of 1 we have another function. And now here you choose a number greater than 1. For example, 2. 3 times 2, 6 minus 2, 4. So at 2 it is 4, 2, 3, 4. So at 2 it is 4. And you connect these 2 points to sketch the graph of the second line. So this is the graph of the piecewise function. This function is similar to the graph of y equals x squared, but there are 2 units to the right. So we know the graph of y equals x squared, but we take it 2 units to the right and we sketch the graph of y equals x squared. Here x plus 1 cube. So this function is similar to the graph of y equals x cube, but we will take the graph of y equals x cube 1 unit to the left. If it is x plus 1, we go to the left. If it is x minus 2, we go to the right. So 1 unit to the left, and we sketch the graph of x cube. Graph each function, find and identify any asymptotes. Well, we have vertical asymptotes and horizontal asymptotes. For the vertical asymptotes, we solve the denominator for 0. So the equation of the vertical asymptote is x equals to 2. For the horizontal asymptote, we have 3 cases. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. The degree of the numerator here is 0. I mean, there is x to the power 0, but we do not write it because it is 1. And in the denominator, we have x to the power 1. So the horizontal asymptote is y equals to 0. So if you sketch the graph of this function, y equals to 0 is the horizontal asymptote, and x equals to 2 is the vertical asymptote. Actually, the graph of this equation is the same as the graph of 1 over x, but taken 2 units to the right. And we know the graph of 1 over x, it's just like this. I can find the y-intercept, okay? Because if I put x0, I can find the y-intercept. So if I put x0, I have 1 over negative 2, so the y-intercept is negative half. And the graph would be like this. So this is the graph of this function. What about this function? For the vertical asymptote, we said we put the denominator equals to 0 and we solve the equation. We get the equation of the vertical asymptote. So x equals to -3 is the vertical asymptote. For the horizontal asymptotes, if we have the same power, here we have x to the power 1 and here we have x to the power 1. So the the equation of the horizontal asymptote would be y equals the coefficient of x in the numerator, which is 2, over the coefficient of x in the denominator, which is 1. So y equals to 2 would be the equation of the horizontal asymptote. So we can sketch the graph of this function. This is y equals to 2. This is the equation of the horizontal asymptote. And this is x equals to 3, the equation of the vertical asymptote. Now to sketch the graph of this function, I have these two lines, these two asymptotes divided the plane into 4 regions. So 4 regions. These 4 regions, okay, this is region 1, this is region 2, this is region 3, and this is region 4. And now the graph of this function would be in 2 of these regions. So how to find out? You go to the vertical asymptote. This is the vertical asymptote. And you look to the number before it, which is -2. And you replace x by -2. So if x is -2, what is y? All right. 2 times -2 minus 1. So -4 minus 1 over -2 plus 3, which is 1. So the answer is -5. So at -2, the answer is -5. So the answer is here. So this means that the graph is in this region. Okay. So how to graph it in this region? We let it approach the asymptotes. It will pass by the y-intercept. You can find the y-intercept easily if you put x0. So at -2, it's -5. And if I put x0, it's -1/3. So here. So the graph would go like this. It will approach the asymptote here, and it will continue here to approach this asymptote. So this is the graph in this region. What about to the left of the vertical asymptote? It is -3. So let me choose -4. So what is the value of y if x is -4? Well, 2 times -4 is -8 minus 1 is -9, and -4 plus 3 is -1. So the answer is 9. So at -4 it is 9. It's up somewhere here. So this means that the graph is in this region, and of course it must approach the vertical asymptote and the horizontal asymptote. So this would be the graph of this function. Notice that the domain here would be all real numbers except -3, in which the vertical asymptote, and the range would be all real numbers except the 2, which is the horizontal asymptote. We can check if the graph intersects the horizontal asymptotes. Let me solve this equation. 2x minus 1 over x plus 3 equals to 2, because the equation of the horizontal asymptote y equals to 2. If there is an intersection between the curve and the horizontal asymptote, then they must be equal. So 2x minus 1 over x plus 3 should be equal to 2. If I multiply cross product, I have 2x minus 1 equals 2x plus 2 times 3, which is 6. If I subtract 2x from both sides, then I'll have -1 equals 6, and this is not correct. So there is no intersection between the horizontal asymptote, and the curve, and the range would be all real numbers except 2. This is an additional information. It is not asked in the question. The supply function for a product is given by this, and the demand is given by this. Find the equilibrium quantity and price. Well, to find the equilibrium quantity and price, the supply has to equal to the demand. Okay, so I have P equals Q square plus 300, and I can solve this equation for P taking negative Q to the other side. And then this is P and this is P. So put the two equations together. So I have Q square plus 300 equals negative Q plus 410. So this P equals to this P. This means you are solving the two equations together. This is a quadratic equation. So I'll take everything to the left-hand side. 300 minus 410 is negative 110. Now you can try to solve this equation by factoring, and you can try to solve it by the quadratic formula. Okay, actually, if you think of factoring, this is Q plus 11 plus 11 times Q minus 10 equals 0. 11 times negative 10 is negative 110. 11 plus minus 10 is 1. So either Q is negative 11 or Q is 10. But negative 11 is rejected because quantity Q represents the quantity and it cannot be negative. So the equilibrium quantity, which I'll call QE, Q equilibrium, is 10. That's the equilibrium quantity. How to find the equilibrium price? Well, I can use this equation, for example. So P would be negative Q, which is negative 10, plus 410. So the answer is 400. So the P, the price, equilibrium price, is 400. So this is the intersection point between the demand function and the supply function. So if you put, for example, here P10, P400 plus 10, you get 410. So it satisfies the demand function. And for the supply, Q square is 100 plus 300 equals to P, which is 400. So also it satisfies the supply function. This means our solution is correct. Well, here, the same question, but the demand is given by this equation and the supply is given by this equation. Now, how to find the equilibrium quantity and price? We need to solve the two equations together. Now, look to the equations. I have P square here and P square here. Well, if I take this P square to the other side, I will have 40 plus 3Q equals to P square. And I have also P square here in this equation. So I will replace this P square by its value from this equation. So I replace P square by 40 plus 3Q plus 5Q equals to 100. Now this is a linear equation, not a quadratic equation. So 5 plus 3, 8Q. I keep Q in this side and take 40 to the other side. 200 minus 40 is 160. And if you divide by 8, you get 20. So Q equilibrium would be 20. Now, how to find price equilibrium? I can use this equation. So P square would be 40 plus 3 times 20, which is 60. So P square is 100. So P would be plus or minus square root of 100, which is 10. But negative 10 is not a possible price. So price equilibrium is 10. Again, if you put Q here 20 and P 10, you will notice that the two equations are satisfied. So 100 plus 100 is 200, and 40 minus 100 is negative 60 plus 60, 0. So our solution is correct. Break-even points. This is the total cost, quadratic function. The total revenue, also quadratic function. Find the break-even quantity. The break-even quantities, we find them when the cost equals to the revenue. So I put the cost equals to the revenue. I have quadratic equation equals to another quadratic equation. So I get a quadratic equation at the end, and to solve it, I take everything to the other side. 0.6 plus 0.4 would be 1. And 8x minus 100x is negative 92x. And I have here plus 1760 equals to 0. All right. Again, you can try to solve this equation either by factoring, although the numbers are uh, large, not easy. But if you cannot factor, you can use the quadratic formula. If A here is 1, B is negative 92, and this is C. And the quadratic formula says x equals negative b, which is 92, plus or minus square root of b square. Well, b square is negative 92 squared, which is large number. It's 8464 minus 4 times a, which is 1, times c over 2 times 1, which is 2. So 92 over 2, that's 46, plus or minus square root of 8464 minus 4 times 1760, that's 1424. And if you ask the square root, uh, there is no square root for this number. So I have it is 4 square root of 89 over 2, and the answer would be 46 plus or minus 2 square root of 89. 4 over 2 is 2. Now this should be the break-even quantity. But let me check whether 46 minus 2 times square root of 89 is negative or positive. Well, it is positive. Okay, it is positive. So I have x, the break-even quantities, either 27.13, which is 46 minus 2 times square root of 89, or 46 plus 2 square root of 89 would be 64.87. So these are two break-even quantities. Here the total cost is linear. The total revenue is quadratic. Find the break-even quantities. The break-even when C equals R. So when 900 plus 25x equals the revenue function. Again, I have a quadratic function, so I take everything to the right-hand side. 25 minus 100 is negative 75x, and I have plus 900. Try to solve this equation either by factoring if it is easy, or you can immediately try the quadratic formula. Actually, here I can find two numbers. Their product is 90 and their sum is negative 75, negative 15, and negative 60. If you multiply 16 times 50, 60 times 15, it is 900. So either here x is 15 or x is 60, and there are two break-even quantities. Maximum profit. This is the cost function, quadratic, and the revenue, quadratic. Find the level of production that gives maximum profit. If he asks about maximum profit, then we have a parabola with a parabola that opens downwards. So the vertex is the maximum point. And when he asks find the level of production, he is asking about H, and find the maximum profit, he is asking about K, because the vertex has coordinates H and K. So first here we need to find the profit function, and the profit function is the revenue function minus the cost function. So the revenue is 50x minus 0.2x squared minus the cost. Now this minus will change all the terms in the cost function. Okay, so the last one also good. So let me write it in order. So negative zero point 0.2, negative zero point 0.2. I have negative 0.4x squared. So A is negative and it will open downwards. 50x minus 10x is plus 40x. So I finished from these two and these two, and I still have negative 360. So this is the profit function. So what is A? Negative zero point 0.4. What is B? It is 40. So H, which is the level of production that give maximum profit, is negative B, which is negative 40, over 2 times A. So negative zero point 0.8. 2 times 0.4 is zero point 0.8. So now I divide 40 by 0.8, and the answer is 50. So this is the level of production that gives maximum profit. Well, if I want to find the maximum profit, I find K. And to find K, I go to the profit function and I replace X or H by 50. So it's negative zero point 0.4 times 50 squared, which is 2,500, plus 40 times 50, because X is 50, which is 2,000, minus 360. And the answer would be 640. So the maximum profit is $640. The last question. A certain company has fixed costs $15,000. So this is the fixed costs for its product, and variable costs given by 140 plus 0.04x dollars per unit. So the cost function, formulate a function for total cost and total revenue. The cost function would be The variable cost, how do we write the variable cost? The price, which is 140 plus 0.04x, okay, times the units per unit. Remember, if the variable cost in the linear form in the previous chapter, if the variable cost is 10, then we write 10x. But now here, the price, the cost price is given with x. So this is the cost price. So you multiply by x, okay, plus the fixed costs, which is 15,000. So I can write it as 0.04 x squared plus 140x and plus 15,000. This is the cost function. Okay. Uh, the selling price is given by this. Notice the selling price has X in it, dollars per unit. So the revenue function, the definition of the revenue function is the price times X. So it's 300x minus 0.06x squared. Find the break-even point, the quantities. The break-even quantities when the cost equals to the revenue. So when 0.04x squared plus 140x plus 15,000 equals 300x minus zero point 0x squared. 0.04 plus 0.06 will give you 0.1. So we will have 0.1 x squared. And then 140x minus 340x will give you negative 160x and plus 15,000 equals to 0. If you want to multiply by 10, okay, or you can use the quadratic formula immediately. If I multiply by 10, then the coefficient of x squared would be 1, and this would be 1600x, and this would be 150,000 equals to 0. I'll try to solve this equation by factoring. So I will search for two numbers. Their product is 150,000 and their sum is 160. And if I use negative 1,500 and negative 100, then the total would be negative 1,600 and the product would be like this. So I have two break-even quantities. Either x is 1,500 or x is 100. So there are two break-even quantities. Find the level of sales that maximize the revenue. Where is the revenue? This is the revenue. You notice that the revenue has a negative coefficient of x squared. This means it's a parabola opens upwards and there is a maximum revenue. So what is A? Negative 0.06 because this is the coefficient of x squared. And B, the coefficient of x is 300. All right, negative 0.06 and 300. We need to find the level of sales that maximize the revenue. That's H. So H is negative B. So it's negative 300 over 2 times negative 0.06. And the answer would be 2,500. So this is the level of sales that maximize revenue. Notice he did not ask about the maximum revenue. If he asks about the maximum revenue, we will find K. Form the profit function. All right. To form the profit function is R, the revenue money minus the cost. So the revenue is 300 minus 0.06. All right. Minus the cost function, which is negative 0.04 x squared. I will multiply all terms by a negative sign, and then negative 140x and negative 15,000. 15,000. All right. So the profit function would be negative zero point 0.1 x squared and plus 160x and negative 15,000. This is the profit function. Find the level of production and sales, which is H, that maximize the profits. So A is negative zero point 0.1, B is 160, and H is negative B over 2 times A. So the answer is 800. So this is the level of sales or production that maximize profits. He did not ask about the maximum profit. If he asks, I will replace X here in the profit function by 800. Find the profit or loss at the production levels found in part C and D. All right. In part C and D. So in part C, the production level is 2,500. He wants the profit, so I need to find the profit of 2,500. So I go to the profit function and I replace x by 2,500. So negative zero point 0.1 times 2,500 squared, okay, plus 160 times 2,500 minus 15,000. The answer is negative 240000. So it's a loss. So pay attention to this important point. The level of production that maximize the revenue will give you a loss in the profits at the end. So we do not need usually to maximize the revenue. We need to maximize the profit, not the revenue. So while if you here find the profit at the level found in part D, which is 800, this will give you the maximum profit. Okay, this will give you the maximum profit. So negative zero point 0.1 times 800 squared plus 160 times 800 minus 15,000, 49,000. So the maximum profit is 49,000. This is actually the maximum profit. So pay attention to this point. We don't need to maximize revenue. We need to maximize the profit. Thank you very much. I hope you enjoyed reviewing chapter 2. Have a nice time.